All right, last day of lessons. We're going to review the converse a little bit more today, make sure we're all on the same page. So, we're going to write converse statements. If two lines are parallel, then alternate exterior angles are congruent. Let's do the converse. If, and now we're going to write the end part first, alternate exterior angles are congruent, then two lines are parallel. Let's do this one now. So if two lines are parallel, then corresponding angles are congruent. Let's write the last part first if it's the converse. So if corresponding angles are congruent, then lines are parallel. And lastly, if two lines are parallel, then same side interior angles are sup. Let's do the converse. If same side sup, then lines are parallel. Okay, so if we can prove any of these three things to be true, we can prove lines are parallel. All right, it's the baby steps into proofs. We'll get there. We'll get there next unit. So you're going to be able to determine for what value of x we need in order for lines to be parallel. And we're going to look at some two-column proofs today just to see what those things are all about. So, to be or not to be parallel, that is the question. So we have angle B is equal to 110 degrees. We also know that angle F is 110 degrees. Wow, what kind of relationship are these? Angle B, angle F, same side of the transversal, one on the outside, one on the inside. We have corresponding angles. Therefore, corresponding angles, 110, 110. Last I checked, those are equal. So corresponding angles are congruent. So, do we have parallel lines? Yes, because corresponding angles are congruent. Therefore, we have parallel lines. So angle Q, line Q is parallel to line R, right? Corresponding angles are congruent, therefore we have parallel lines. Let's try another one. To be or not to be is the question. Are they parallel? Angle D, 85 degrees. Angle F, 96 degrees. Well, let's look at the relationship. We've got two angles on the inside of my parallel line, so they're interior. They're on the same side of my transversal, so we have same side interior angles. Well, if we have parallel lines, we would have same side sup. Do we have supplementary angles? Let's check. 85 plus 96 is, drum roll, sorry, 181 degrees. 181 is not equal to 180 degrees. Therefore, are they parallel? No. Not same side sup, right? They're not parallel lines. All right, let's take a look at another one. Let's see if we can do this one. So, we got a new one. So now we want to determine what value of x we need in order to prove parallel lines, right? So we want to prove line L parallel with line M, which means we want the converse to happen. So if I look at angle 4 minus 5x, right, and I look at angle 7x plus 100, these two guys are on the same side of our transversal, this blue line, but one's on the inside, one's on the outside. So I have corresponding angles, right? Corresponding angles, we need to be congruent to prove parallel lines, which means I got to set these guys equal to each other, right? 4 minus 5x equals 7x plus 100. I'm going to add 5x to both sides of the equation, giving me 12x plus 100 and 4 by itself over here. I'm going to subtract 100 from both sides, giving me negative 96 equals 12x. I'm going to divide both sides by 12. 96 divided by 12. So negative 8, because I have a negative and a positive. So x equals negative 8. So when x equals negative 8, that would make both of my angles the same measure, right? And if you want to figure out what the same measure is, just plug it back in. So negative 4 minus 5 times x. Well, 5 times x is going to be negative 40. 4 minus a negative 40 is going to give me 44 degrees, right? So this angle is 44 degrees. Therefore, this angle is also going to be 44 degrees. And we will have corresponding congruent angles. And you can check this one too. 7 times negative 8 is going to be negative 56 plus 100 would also be 44 degrees. All right. All right, see if you guys can do this one on your own. Pause the video and let's come back and see how we did. So again, I'm trying to prove parallel lines, which means I have an angle here and I have an angle here. Well, what's the relationship? One's on the outside, one's on the inside, same side of my transversal. I have corresponding angles again, which means I need them to be congruent. So set them equal, right? 14x plus 9 equals 5x plus 90. Balance our equation, so we'll subtract 5x from both sides. I get 9x over here plus 9 equals 90. Subtract 9 from both sides, giving me 81, and divide by 9. So x equals 9. So again, I now know that these two angles are going to be congruent, and therefore corresponding angles are congruent. My lines are parallel based on our converse. All right, let's try one more and then we'll take a look at a proof. So we need to find what values of n will make our lines parallel. Again, what's our relationship? Well, I've got two angles. They're both on the outside, so they're exterior angles, right? But they're on opposite sides of our transversal, so we have alternate exterior angles, which means we need them to be congruent. So let's set them equal to each other. N squared equals n plus 56. Again, we have another quadrilateral, so I need to make it all balanced, which means I need 0 on this side of my equation. So I'm going to subtract n and 56 from both sides, giving me n squared minus n minus 56 equals 0. Now I can solve my quadratic by factoring. I need two factors that multiply to negative 56 and adds to negative 1. Remember, there's a 1 here. So I've got 8 and 7. Since it's a negative 1, I need 8 to be negative. So I get n minus 8 and n plus 7. Well, that's going to give me two solutions. N equals 8 or negative 7. I need to plug them both back in, make sure they both work, right? 8 times 8 is 64, so this one will work on that angle. Negative 7 times a negative 7 is going to give me positive 49, so that one works, right? 8 plus 56 will give me 64, so that works. And negative 7 plus 56 will give me 49. So both of these solutions will work. So n needs to be 8 or negative 7 in order for lines to be parallel, right? So we're trying to find the value that makes the relationship happen so we can prove parallel lines. All right, so we're going to take a look at a two-column proof. You'll see more of these coming up, but we just want to show you what it looks like today. So two-column proofs, why do we call them two columns? We got two columns, right? One side we say statements, the other side is our reason. So this is what we can say, and this is why we can say it. So let's look at some of these. So I've got Angle 2 over here, right, is going to be congruent to angle 1. So I can mark those congruent. And then it says that angle 1 is congruent to angle 3. So angle 1 is congruent to angle 3. Right? I am trying to prove that AB is parallel to CD. So let's highlight that, right? So AB parallel to CD, right? And so if I look at the transversals that I have, it's either going to be AD, BC, or CA. Well, if I highlight CA, I already have two angles that are congruent. That'll help me prove these lines are parallel, right? Angle 2, angle 3, those are on opposite sides of the transversal inside my parallel lines. So I have alternate interior angles congruent. So that's how I'm going to prove these lines are parallel, right? Again, we will talk more about two-column proofs later, but I just want you to see what they look like right now. So first, you write your given. That is the first step in every proof. So first, I'm going to write angle 2 congruent to angle 1, and angle 1 congruent to angle 3. And I'm going to say given is my reason, because it was given. Now, I can prove angle 3 is congruent with angle 2 because 2 is congruent to 1 and 1 is congruent to 3, so I can create a train, right? So I'm going to say angle 2 is congruent to angle 3. And we can either say transitive property, because that's what that means, or an easier way of saying it is substitution, right? I'm going to put in angle 2 where I see angle 1. So this is because of substitution, right? I've substituted in angle 2 for angle 1. So substitution is the reason here. And the last step is I have angle 2 and angle 3, which are corresponding angles, and they are congruent, so I can now say AB is parallel to CD, right? And that's because if corresponding angles are congruent, then parallel lines, right? So proofs are all about the logic. We're using reasons to get from one place to the next. It's a very logical process, all right? So let's look at one more, and then you can see how you're doing on the homework. Again, you will not be responsible for proofs for this test, for this unit, but they will come back eventually, right? So again, we have angle 5 and angle 6 are supplementary, and we're trying to prove AB is parallel to CD. Well, let's take a look at this. First step, I'm going to write the given, right? Angle 5 is sup to angle 6. And again, our reason is given. That seems easy, right? And then I have angle 5 and angle 6 are supplementary. Well, if I highlight this transversal, so CA, 5 and 6 are going to be on the same side of that transversal, and they're going to be inside my yellow lines, which I'm trying to prove parallel. So 5 and 6 are supplementary. That's given. We can prove they're parallel based on that information. So because same side sup, I have AB parallel to CD by if same side sup, then lines parallel. Isn't that fun? All right, so next time we meet in class, we'll be reviewing. Hopefully we're all on a good note, and we'll see you soon.